Hey, Tony here from empowermefirst.college. We have an equation for which we have to find the gradient at the point where x equals 2 and y equals 16. And we are also told that x is not equal to 0. If x was equal to 0, this here would be undefined. If we have a linear equation, let's say that this is a straight line, the rate of change along the line stays the same. What I mean is that between this point and this point, as well as between this point and this point, the distance by which the slope rises is the same if the distance between each point is the same. So same run means same rise. Here, let's say we go 2 in this direction. Let's say we have 3 here and 5 here. So when we go from 3 to 5, we can say we go, for example, here from 2 to 3. And then going from 5 to 7, 2 more, we will have also, as we had 1 more here before, we would also have 1 more here of rise. So we would be here at point 7.4 and here at point 5.3 and here at point 3.2 and so on. So this is for a straight line. We can see here that x is squared. This indicates that we are dealing with a curve and not a straight line anymore. We don't have a straight line, but we have something like this. This is because when we take x and we square it, it doesn't matter if it's positive or negative, we're going to end up with a positive number. The curve can look like this, or more like this, or more like this. How low is the lowest point depends on this second term here. And because we are dealing with a curve, it means that the gradient, that is the same to say that the slope of this curve, is different at different points. Here we have a given gradient or a given slope, and here we can see it is less slopey, and we can also see that we are dealing with a negative slope here on this side, and from somewhere here we move to a positive sloping curve. The curve is going up, and the way we find the slope at a given point is by taking the derivative of this equation and then plugging the value for x into that new equation that corresponds to the derivative of this one. So we can call the derivative y prime, and first dealing with the first term, the way we apply the power rule is by taking the exponent and putting it in front. So we have 2, and then the exponent of x is reduced by 1. So we have x and would be to the first power. But x to the first power is the same as x, so we're just going to write x. And for the second term, we have a division, and in this case, we use the quotient rule. To apply the quotient rule, we go as follows. We do low times d high minus high times d low, all this over low or low squared. By low, we mean denominator. By high, we mean numerator. If we plug the numbers for our second term, low is x, that gets multiplied by the derivative of high. High is 24, and the derivative of a constant is 0. And to this, we have to subtract high, which is 24, times the derivative of low. What we have is x to the first power. We take this 1, we put it in front of the x, and the power of x gets reduced by 1, meaning we have x to the 0. Any number to the power of 0 is 1. So this is equal to 1 times 1, which is 1. This means that here we have 24 that is multiplied by 1. All this over low, so x squared. And the value we have to use for x is 2. So at the numerator we have minus 24. The denominator we have 2 squared, which is 4. All this gives us a minus 6. This whole thing here is equal to minus 6. So the derivative of y is 2x plus minus 6, meaning minus 6. Our 2x equals 2 times 2, which is 4, and minus 6. Our y prime is equals to minus 2, which is the gradient of our curve at the point where x equals 2 and y equals 16. So we have answered the question. The gradient of this equation at this point equals minus 2, meaning that if we graph our curve, say x equals 2 and y equals 16, at this point the curve is downward sloping because we have a minus sign.